You know, we use numbers every single day. They feel so solid, right? So real, so fundamental. But what if there's a point where all that breaks down? A point where a number gets so unbelievably huge, it just stops being a number at all?
That is the wild idea we're going to dive into today. It's a question that seriously challenges the very foundation of what we all think we know about math. It suggests that maybe, just maybe, some of the biggest numbers we can possibly imagine are really just empty symbols with no real meaning behind them. So, this whole fascinating debate got kicked off by a video about large numbers. But what came next wasn't just some simple disagreement. Oh no. It was a critique that spiraled into a deep philosophical argument about the very nature of mathematics itself. Now, to be clear, we're not here to pick a side, but we are going to unpack these ideas because honestly, they are genuinely mind-bending.
Okay, so let's break down the central conflict here. It really all boils down to two completely different ways of thinking about what a number even is.
This lays out the two opposing camps perfectly. On one side, you've got the common view in math. A number is an abstract idea. It exists whether we can write it down or not. But on the other side, there's this radical alternative. For something to truly be a number, it has to have a physical, identifiable component. I mean, if you can't even distinguish it from another number, is it really a number at all? That's the question.
To make this a little more concrete, the whole debate centered on a specific example. And the critics' response to it was, well, let's just say it was pretty surprising. This number is a googol. Yep, that's a 1 followed by 100 zeros. It's the classic example of a mind-bogglingly huge number. It's way more than the estimated number of atoms in the entire known universe. So it's big, right? It has to be.
Well, according to the critique, no. The claim is that a googol is actually a small number. I know, that sounds completely absurd, but hang on, because there's a very specific logic behind saying that.
And this gets right to the critic's core point. The reason a googol is considered small in this argument is simply because it's identifiable. We can write it out. It has a concrete, physical representation. That ability to pin it down is the key. So, what happens when you lose that ability? This leads us to the most fascinating part of the critique, a concept called the gray area. This is where things get really weird, and the line between a number and a meaningless symbol just starts to completely blur. So the critic proposes this theoretical limit, one that's based on our physical universe. Imagine a number so colossal that you couldn't possibly write it down, even if you could use every single atom in the universe as a bit of ink. The argument is that at this point, it's just not a number anymore. It's lost its identifiability. It's become just a symbol, floating around in pure abstraction. So this is the breakdown. First, you have your writable numbers, like our friend the googol. We can handle those. Then you have symbols for quantities that are physically impossible to write down. And that final step is the gray area, where these symbols become functionally useless. I mean, as the critic asks, how can you add 1 to a number you can't even identify? According to this view, you just can't. And the conclusion that's drawn from this whole line of reasoning is a really powerful challenge to our common understanding of mathematics. This quote from the source material really hits home. The argument is that math starts to break down long before we even get to the concept of infinity. This gray area isn't at infinity's edge. It's a vast territory where things we thought were numbers are, well, just not. So what's the root cause of all this? According to the critic, it all comes down to a fundamental problem of definition within mathematics itself. This whole argument extends way beyond just big numbers. The critic claims that modern mathematics is operating on some seriously shaky ground, using basic building blocks that lack solid, rigorous definitions. Words like number and infinity, they argue, are used loosely, and that leads to exactly these kinds of conceptual paradoxes. And just to present the full picture, the critic isn't just pointing out problems. They also propose their own alternative system, arguing that it provides a more solid foundation for both mathematics and physics. But really, the core debate here isn't about their solution. It's about the problem they identify. And that leaves all of us with a really fundamental question. Is math a purely abstract world of ideas, existing totally independent of our physical reality? Or does it have to be bound by the limits of our universe for its concepts to have any real meaning? It's a question with no easy answer, and it might just change the way you look at every number you see from now on.